Okay, so our question asks, how much current flows through the bottom wire in figure 32.69 and in which direction? So what we have here is a 9-volt battery and a 15-volt battery, and then 4 different resistors, all clearly labeled as 6 ohms, 10 ohms, 12 ohms, and 24 ohms. So the first thing we're going to do here, we're going to label all of our currents. As you can see, we have different nodes, and everywhere there's a node, the current is going to stop. So we have I1 going here and around the corner, and it stops there at the node. And then we have I2 starting down here, going up and around the corner, again stopping at the node. I3 going from this node to this node. I4 going from this node to this node, and I5 going from this node to this node. Remember, it doesn't matter which direction you draw your currents in. They're really just helping with calculations. So if you go through your calculations and you get a negative answer, that just means that you drew your current in the wrong direction and that the actual current is in the opposite direction. Next, what we're going to do is we're going to use Kirchhoff's loop rule, and we're going to draw in loops. And as you can see here, I drew in loop 1 here, loop 2 over here, and loop 3 over here. And basically what Kirchhoff's loop rule means is that the voltage all the way around a loop is going to be equal to 0. Since not all the voltages are explicitly given to us, we have to also use the equation voltage equals current times resistance. So in the case of loop 1, we're going to start over here with 9 volts. And since we're going from the negative end of the battery to the positive end in our loop, it's going to be a positive number, positive 9 volts, as you can see here. Then we're going to go up here to our 6 ohm resistor, and since we're going with the direction of the current, it will be a negative number. So we'll use V equals I times R, so we'll have I1 times 6 ohms, and that's all going to be negative. Then we're going to come down here, again within our loop, and we're again flowing with the direction of the current, so our number will be negative. So we'll have negative I3 times 12 ohms. This will ultimately give us this equation, which simplified and solved for I1 will give us this equation. Loop 2 and loop 3 will be done similarly to loop 1. You just have to remember that when it comes to the batteries, if you're traveling from the negative end to the positive end, then your voltage will be positive. And if you're traveling from the positive end to the negative end, then your voltage will be negative. You should also remember that when you're using V equals I times R, if your loop is in the direction of the current, then your voltage for said number is going to be negative. Also, if it is against the current, then your number will be positive. As you can see here, if you've solved for loop 2 and loop 3 properly and simplified, you should come down to these two equations down here. Now we're going to use our junction rule, the Kirchhoff's junction rule, which means that the total current into a junction should equal the total current coming out. So referring back to our picture, you can see up here that the current I should equal the current I3 plus I5, because I1 is going in and I3 and I5 are coming out. Likewise, the current I4 should equal the current I2 plus the current I5. Combining the equations that we got using the junction rule and the loop rule, we can come down to these two equations here. Now we can use these two equations and set them equal to each other and utilize the equation that we got calculating loop 3 to set the entire equation in terms of I3 and then solve for I3. And then once we do that, we can plug in I3 back up here to solve for I5. Now once we solve for I5, you should get that the current along the bottom wire is negative 2.1 amps. In reality, current can't be negative, so our actual answer is positive 2.1 amps. The negative simply means that it's traveling opposite from the direction that we initially drew. So it should be traveling in directions from left to right. Our final answer should be positive 2.1 amps traveling from left to right.